Hey 8th graders, really quick video for you guys. I'm just going to go through a couple things, so if you guys have something that needs more better explanation, you guys have it here for you. So this is part 1 that you guys are going to be doing today. Tomorrow you guys will do part 2, so stay tuned for another little short video there. But basically throughout this whole review, you guys are looking to the fact that you can differentiate between temperature and thermal energy. You can predict the transfer of energy in a system until the system reaches equilibrium. You can explain how objects of different sizes have different thermal energies, and you can explain why some objects feel hot while others feel cold. All right, so moving on. Again, this is part 1. Slide 3, what is kinetic energy? That should be in your notes. What is the difference between thermal and kinetic energy? Again, that should be in your notes, so you guys can go check that out. If not, you guys can go dig through old assignments where you guys should have been putting stuff in your OneNote. Okay, on this one, you guys can calculate thermal energy. I'm going to go ahead, or excuse me, averages here. So I'm going to go ahead and put a little calculator down here for you guys in case you need it, but you also have a calculator on your computer. Remember that you are adding up the numbers to find the averages and then dividing through by the number of things that you added up. So in this first one, you have 1, 2, 3, 4, 5, 6, 7 numbers. So add them up and then divide by 7. Okay, so make sure you guys divide on all of those. The number that you guys get for your average should represent that group of numbers and not be way higher than them. Okay, on your next 3 slides, you guys are given 3 scenarios, and what you guys are going to be doing is using your draw tool to highlight which scenario fits. So first and foremost, I want you guys to pick a highlighter that I can see. I prefer like a dark pink or a dark orange. Okay, so in the following statements of the 3 options, highlight the one in which the molecules move faster. So we're looking at the ones that had the higher average kinetic energy, the ones that have the higher temperature. Those are the ones that are going to be moving faster in that sample. No matter the size of the sample, we're just looking at molecule speed within that sample. So if we look at our first one, 20 milliliters of water at 87 degrees Celsius, or 20 milliliters of water at 78 degrees Celsius, or both are the same, only one of those are correct, and it happens to be this first one. They're the same size, but size doesn't matter when we're looking at molecule speed. Okay, so we're looking at the one with the higher temperature, tells us they all have a higher kinetic energy, therefore are moving faster. Okay, so go through the other ones of these. You got 1, 2, 3, 4, 5 more examples to do. Again, there's 3 options. Choose the one option that has your molecules moving faster. Okay, for this one, same setup where you guys have 3 options and you guys are choosing one. This one, you guys are looking at a lower average kinetic energy. So remember, if you have a lower average kinetic energy, you have a lower temperature, and you guys have a lower speed. Okay, they're moving slower. So looking at these, again, we're looking at average kinetic energy. So the size of the samples don't matter in this scenario. Okay, finally, in the following statements of the 3 options, highlight the one in which the molecules have a higher thermal energy. So this is the big one. This is where the size of the sample does matter, because the more you guys are looking at thermal energy, and thermal energy is the total kinetic energy of all the molecules. So the more molecules you have, chances are you're gonna have a higher thermal energy as well. So really take that into consideration. If the samples are the same size, then we're gonna be adding up all the kinetic energies of the molecules. So if we have one sample that has a higher temperature than the other, that one's still gonna have a higher thermal energy even though those samples are the same size. So really keep that in mind as you guys go through this. If they're the same size, which one's got a higher average kinetic energy? And if one is larger than the other, what do the temperatures look like? And which one's the larger sample? Because larger samples mean more molecules, which mean a higher total kinetic energy or thermal energy. All right, so that's part 1 for you guys. From there, you guys can go back, check your answers, and then we will move on to part 2 tomorrow.